According to the National Electrical Code, specifically Article 500, the assertion that a Class 1 Group C device should be installed in a Class 1 Group D environment is incorrect. Section 500.8 of the NEC clearly states that equipment must be approved for the location in which it is installed. This requirement emphasizes that equipment must be specifically listed for the hazardous location classification where it will be used. In the instance described, the equipment in question is listed as either Class 1 Group C or Class 1 Group D, and crucially, not both. This distinction means that it is non-compliant with the NEC to install the Class 1 Group C equipment in a Class 1 Group D environment because it lacks the necessary approval for that specific location. The rationale presented, that Group C is supposedly more hazardous, is misleading and inaccurate. While it is true that Group C and Group D locations present different types of hazardous conditions, it is not accurate to suggest that one is inherently more or less hazardous than the other. The key difference lies in the nature of the flammable gases or vapors present and the likelihood of their release under normal operating conditions. Group C locations are characterized by flammable gases or vapors that are not typically expected to be released during standard operations. Conversely, Group D locations involve flammable gases or vapors that have a higher probability of release under normal operating conditions. For the scenario outlined, it is essential that the equipment installed in a Class 1 Group D environment be explicitly listed as Class 1 Group D. The NEC stringent requirements for hazardous location equipment aim to ensure safety and prevent explosions or fires. This is achieved by mandating that the equipment is tested and certified to withstand the specific conditions present in each classified location. Firstly, understand the fundamental principles of hazardous location classification, which is critical for safe electrical installations. Hazardous locations are classified based on the type of hazardous material present and the likelihood of its presence in ignitable concentrations. The National Electrical Code, NEC, Article 500, provides detailed guidance on these classifications and the requirements for equipment installed in such locations. The NEC divides hazardous locations into classes, divisions, and groups, each representing a different type of hazard. Class 1 locations involve flammable gases or vapors, Class 2 locations involve combustible dusts, and Class 3 locations involve ignitable fibers or flames. Divisions indicate the likelihood of the hazardous material being present. Division 1 indicates that the hazardous material is normally present or may be present frequently, while Division 2 indicates that the hazardous material is present only under abnormal conditions. Groups further categorize the specific hazardous materials within each class. For Class 1 locations, the groups are typically A, B, C, and D, each representing different flammable gases or vapors. The specific gases or vapors included in each group are defined by their ignition temperature, explosion pressure, and other characteristics. Secondly, know the specific requirements for Class 1 Group C and Group D locations. Class 1 Group C locations involve atmospheres containing ethyl ether, ethylene, or gases or vapors of equivalent hazard. These substances pose a significant explosion risk due to their low ignition energies and high flame propagation rates. Class 1 Group D locations involve atmospheres containing acetone, ammonia, benzene, butane, gasoline, hexane, methane, natural gas, propane, or gases or vapors of equivalent hazard. These substances are commonly encountered in various industrial and commercial settings and also require stringent safety measures. Equipment intended for use in Class 1 Group C or Group D locations must be specifically designed and tested to prevent ignition of the hazardous atmosphere. This includes features such as explosion-proof enclosures, intrinsic safety barriers, and non-incendive components. Explosion-proof enclosures are designed to contain an internal explosion without allowing it to propagate to the surrounding atmosphere. Intrinsic safety barriers limit the energy available in electrical circuits to levels below what is required to ignite the hazardous atmosphere. Non-incendive components are designed to not produce sparks or hot surfaces capable of igniting the hazardous atmosphere. Thirdly, consider the importance of equipment listing and labeling. Equipment that is approved for use in hazardous locations must be listed and labeled by a recognized testing laboratory such as Underwriters Laboratories, UL, or Intertek et al. The listing and labeling indicate that the equipment has been tested and meets the applicable safety standards for the specific hazardous location. The equipment label typically includes information such as the class, division, and group for which the equipment is approved, as well as the manufacturer's name, model number, and other relevant information. It is crucial to verify that the equipment is listed and labeled for the specific hazardous location where it will be installed. Using unlisted or improperly labeled equipment can create a significant safety hazard and may violate the NEC requirements. Fourthly, address the common misconceptions about hazardous location ratings. It is a common misconception that equipment approved for a more hazardous group can be used in a less hazardous group. For example, some believe that equipment approved for Class 1 Group B can be used in a Class 1 Group C or Group D location. However, this is not always the case. The NEC requires that equipment be approved for the specific hazardous location where it will be installed. While some equipment may be approved for multiple groups, it is essential to verify that the equipment is specifically listed for the intended location. Another misconception is that the degree of hazard is solely determined by the group classification. In reality, the degree of hazard also depends on the likelihood of the hazardous material being present, as indicated by the division classification. A Division 1 location, where the hazardous material is normally present, is generally considered more hazardous than a Division 2 location, where the hazardous material is present only under abnormal conditions. Fifthly, discuss the implications of installing a Class 1 Group C device in a Class 1 Group D location. Installing a Class 1 Group C device in a Class 1 Group D location is a violation of the NEC requirements. The Class 1 Group C device is not designed or tested to withstand the specific conditions present in a Class 1 Group D location. This can create a significant safety hazard, as the device may not be able to contain an internal explosion or prevent ignition of the hazardous atmosphere. In addition, installing unapproved equipment can void the equipment warranty and may result in liability in the event of an accident. It is essential to always use equipment that is specifically approved for the intended hazardous location. Sixthly, emphasize the importance of proper installation and maintenance. Even if equipment is properly listed and labeled, it is crucial to ensure that it is installed and maintained correctly. Proper installation includes following the manufacturer's instructions, using the correct wiring methods, and ensuring that all connections are tight and secure. Regular maintenance is also essential to ensure that the equipment continues to function properly. This includes inspecting the equipment for damage, cleaning it regularly, and replacing any worn or damaged parts. Improper installation or maintenance can compromise the safety of the equipment and may increase the risk of an explosion or fire. Seventhly, highlight the role of qualified personnel. Electrical work in hazardous locations should only be performed by qualified personnel who have received specialized training in hazardous location electrical systems. These individuals should be familiar with the NEC requirements, the different types of hazardous locations, and the proper installation and maintenance procedures for equipment used in these locations. Using unqualified personnel can create a significant safety hazard and may violate the NEC requirement. It is essential to verify that the individuals performing electrical work in hazardous locations have the necessary qualifications and experience. Eighthly, review the relevant NEC sections. The NEC contains numerous sections that address hazardous location electrical systems. Some of the most relevant sections include Article 500, which provides general requirements for hazardous locations, Article 501, which covers Class 1 locations, Article 502, which covers Class 2 locations, Article 503, which covers Class 3 locations, Article 504, which covers intrinsically safe systems, and Article 505, which covers zone classification. It is essential to consult the NEC for detailed guidance on the requirements for specific hazardous locations. Ninthly, discuss the importance of documentation. Proper documentation is essential for hazardous location electrical systems. This includes maintaining records of equipment listing and labeling, installation and maintenance procedures, and any inspections or repairs that have been performed. Documentation can be used to demonstrate compliance with the NEC requirements and can be valuable in the event of an accident. It is essential to keep all documentation up to date and readily accessible. 10thly, provide additional resources for further learning. There are many resources available for individuals who want to learn more about hazardous location electrical systems. These include training courses, seminars, and publications from organizations such as the National Fire Protection Association, NFPA, the International Society of Automation, ISA, and the Institute of Electrical and Electronics Engineers, IEE. Consulting with experienced professionals in the field is another valuable way to gain knowledge and expertise. By understanding the fundamental principles of hazardous location classification, following the NEC requirements, and using properly listed and labeled equipment, it is possible to create safe and reliable electrical systems in hazardous locations. Ignoring these guidelines can have severe consequences, including explosions, fires, injuries, and fatalities. The NEC hazardous location requirements are intended to minimize these risks and protect people and property. Therefore, adherence to the NEC is not just a matter of compliance, but a matter of safety. Remember that hazardous locations pose unique challenges that require specialized knowledge and equipment. The information provided here is intended to offer general guidance, but it is not a substitute for professional engineering advice. Always consult with qualified professionals and refer to the latest edition of the NEC for specific requirements. Furthermore, stay informed about changes and updates to the NEC, as hazardous location requirements are subject to revision based on new technologies and evolving safety standards. By taking these steps, the safety and reliability of electrical systems in hazardous locations can be ensured.